This is linear equations in two variables. Standard form for linear equations in two variables is ax plus by equals c. So we'll be finding all the solutions for x and y. X plus y equals 5. Think of solutions. Well, you're saying x could be 1, that would make y 4. Okay, maybe somebody else said 2 and 3. Maybe 3 and 2. I think we better get to a new board because we're running out of space here. So let's just switch this around so that we can have the y by itself. And to isolate the y, well, you wouldn't even have to do that really, in all honesty. You know they're adding to equal 5, so let's just start at 1, 4, 2 and 3, 3 and 2, 4 and 1, 5 and 0. Can we keep going? Absolutely, we could go 6, -1. Or we could go up here, 0, 5, -1, 6. Do you see how we're going to have infinite number of solutions? Because basically what you're making sure of is that these two add to equal 5. Because there's infinite solutions, I suggest you go to a graph, and that would make it easy to say, hey, this goes on and on forever. Go into a graph, plot the points. This is your x, this is your y, this is your x-intercept. Your y-intercept is like a ballerina, she stands on one leg. Your y always follows the x. So we have x is -1, y is 6. When x is 0, y is 5. When x is 1, y is 4. You might notice these points are what we call collinear, because they're all lining up on a straight line. Get out a ruler, extend that line, and there's your solution. Any point that falls on that line solves the problem. That line can go on and on forever, just as your options of solution could have. Now you might get into a standard problem where it says, is this a solution? Remember, this is your x value, he comes first. This is your y value. She's always dependent of the independent variable. And I do, in my function lesson, talk about it like a couple dating. That's why you heard me say he and she. So we just plugged in. For the x, we'll plug in 0. For the y, we'll plug in 3. 3 times 0 is 0. Follow your order of operations. Going down, because you're not solving for a variable. 5 times 3 is 15. Now we add those together, we get 15 equals 15. Yes, that is a solution. Now 8 and 1. 8 is your x, 1 is your y. 3 times 8 plus 5 times 1 equals 15. 3 times 8 is 24, and we have a problem, don't we? That one's not going to be equal. So no, it's not a solution. Okay. In this lesson, it's real important that we graph these sometimes, as I showed you a minute ago, because they have unlimited number of answers. Easiest way to graph is to consider on the graph, on the x-axis, the y value, if we count the y-axis going this way, this is 1, this is -1, this would be 0 on the x-axis. So if you plug in 0 for y, what value does x have to make that true? If you say it would be 2, you are correct. Another way you could do that is you could take 2x equals 4 and solve. and you could get x equals 2. So when y is 0, x is going to be out here at 2. Now, we do the same thing for the y-axis, and we say, well, the x value, here's -1, here's 0, and here's 1. So, the x value on the y-axis is 0, so 2 times 0 plus y equals 4. Well, 2 times 0 wipes out, y equals 4, so we go up to the point of 4. Now, to make sure that we've got a straight line going on, I would plug in 1 for an x and see what y would be. So 2 times 1 is 2. 2 plus 2 is 4. So x is 1, y is 2, and we come out with a collinear line, just to make sure it's collinear. Okay? You wouldn't always have to use 1, but I just want to use something in between them so I can make sure that it lined up. Now let's look at another kind of graph that you may have to graph. That is if we have x equals 3. And I say graph it. I had one student who said she always remembered this by just saying it cuts through the axis, wherever that number is, if there's no other letter. So it's the x-axis, it would just cut through at 3. Now let's make sense of this though. If we make up the points, x is 3, it doesn't matter what the y is, it doesn't affect it. Y could be -5, y could be 0, y could be +5. So at 3, 0, at 3, 5, and at 3, -5, there's the collinear lines, or points that line up for the line. Now another example would be y. Let's give a graph here. Let's say it's y equals -4. This time it cuts through the y-axis. So we come down to 4, -4, draw our line right through the y-axis. To make sense of it, no matter what x is, x can be -5, it's still -4 on the y. X could be 0, it's still -4 on the y. X could be 5, it's still -4 on the y. It won't change. So that's how we get the straight line going that way. Okay. Special thing happens with your standard equation. If you go to graph it and c is equal to 0, watch what happens. 2x minus 3y equals 0. Well, we plug in 0 for y. That'll wipe out. 2x equals 0. 2 times what equals 0? Well, 2 times 0. Okay. So on that one, you just know that it's crossing at 0, 0. You don't have other points. So in this case, we need to plug in some other points here. Let's go ahead and plug in when x is, let's say, when x is 3. 2 times 3 would be 6. Now the reason I chose 6 is because I knew that 3 times 2 could equal 6. And that gives me that it's equal to 0. So we know it went through at 0, 0. Now we know that it also goes through at 3, 2. So over at 3 on the x, up to 2 on the y. Anytime you have an equation set to 0, you're going to have this where it goes through at 0, 0. Let me show you again. Let's do x plus y equals 0. If we wipe out this y, if we put 0 in for y, we have to have 0 for x, because 0 plus 0 equals 0. So that's how we know the point is 0, 0 again. Now choose another point. Let's say x is 1. What would y need to be? You're saying -1, you're correct. So when x is 1, y is -1. But it cuts right through there again. Because these go right through the 0, we call them direct proportion. And there are a few other names that come up sometimes, but I just want you to know that there is a name for them, and that in that case with the 0, you have to come up with some other numbers to find your points. We'll see you in class tomorrow. We're bringing a lot of questions with you. Thank you.